Welcome to the review for the Unit 2 test. What I'm going to do is I'm going to flash pictures up, and the best way to do this is to pause it, answer the question, and then listen to my answer. So I may even give you a handout. I haven't decided yet. We'll see. So your PSAT score states that you will score in the 77th percentile. What does this mean? Well, what this is, so pause. All right, good. You have your answer now. What does this mean? This means you scored higher than 77% of the people that took the exam. So if 100 people took it, and we ranked those scores 1 to 100, you would be number 78 because you scored better than 77 of those people. And I got 2 questions here, so let's do them one at a time. What does z-score describe? If I tell you I have a z-score of 1.2, what does that z-score represent? Pause and answer. Okay, now that you have your answer, we would say a z-score of 1.2 represents a data point or a datum that is 1.2 standard deviations above the mean. Remember that z-scores do not have units. They're units, there's no feet, there's no centimeters. It is just number of standard deviations above the mean. So then, what is the mean and standard deviation of the z-scores of any normal distribution? So if we took all the data points of any normal distribution, we turned them all into z-scores, what would be the mean and the standard deviation? Pause, think about it, and come back when you got an answer. Okay, so you're back. The mean and standard deviation. Well, if we turn everything, every data point into a z-score, we get a normal distribution. And in a standard normal distribution, the mean is 0, and the standard deviation is 1. We get that traditional normal distribution with 0, 1, 2, 3. So, what are the key features of the normal distribution graph? List what we know about this curve. There's a lot going on here, so think about it, write a whole bunch of stuff down, do a bunch of sketches, pause, and when you got it all done, come back. All right, so you're back. Well, the first thing we know that directly under the peak is the mean. That's our first point. The other point we know is that right here and right here, where it changes from concave down to concave up, the inflection point is 1 standard deviation away from the mean. And then we can also mark off approximately minus 2 sigma and minus 3 sigma and plus 2 sigma and plus 3 sigma. And those are the points that are there. So what do we know about the curve? So those are the key features of it. The area under the curve total is 1. But we also know that between this point and this point is 0.68% of the graph, or 68% of the individuals in the data set. We know that between here and here is 95% of the graph, or 95% of the individuals in the data set. And we know between here and here, 3 standard deviations above and below is 99.7% of the data set, or almost everything. All right. We also know that we can cut it up into little pieces. We know that half of the data set is above the mean, and half of the data set is below the mean. And we can start doing little pieces like 0.34 or all those other pieces that are necessary. But we can cut this curve all up. So we measure the height in inches of all class members using markings on the board. We find the mean is 68 inches with a standard deviation of 4.5 inches. After school, we were that the markings were all too high by 3 inches, so a measured value of 70 was actually 67. What is the new mean and standard deviation? So we need to subtract 3 from each data point. So pause and tell me what the new mean and standard deviation is, and I'll wait. Do the math and come back. All right, so you're back. So the new mean would be 65 inches because we would subtract. But the standard deviation would still be 4.5. Because remember, if we add or subtract every data point, the measures of spread do not change. So we did this all in inches. So it says if we change the units to feet, what are the new mean and standard deviation? Well, to change it, how many inches in a foot is 12, so we'd have to divide our data set, all of these data points, by 12. And so here, what are the new ones going to be? So pause and come back when you have an answer. All right, good, you're back. So we would just divide these by 12. So this is inches, this is inches. Our new one would be 5.417 feet, because we divide 65 by, this is just 65 divided by 12. And our new standard deviation, if we were in feet, is just 4.5 divided by 12, or 0.375 feet. Because we do divide. If we multiply or divide, it applies to both measures of center and spread. Neither one of these conversions, though, would change the shape of the distribution. The distribution would have the same shape. The scale would change, but the shape, overall shape of the distribution would stay the same. All right. 68% of my Algebra 2 students scored between 69 and 81. If the scores are normally distributed, what is the standard deviation? Pause for a second. Think about it. There's a hint up here, but pause and come back when you think you have an answer. All right, so you're back. So think about this. If I draw a normal distribution, and I tell you that 68% is a warning, that's like bells ringing. That's going to be one standard deviation above and one standard deviation below on a normal distribution. So if this is 69 and this is 81, then the mean has to be halfway in between. If you do 81 minus 69 and divide it by 2, you get 6. So 69 plus 6 is this mean of 75. So if the mean is 75, then the standard deviation is this distance here, which is 6. So we would say the standard deviation is 6 points, or 6 points, because we're talking about a test. Right. Does everybody understand that? Because this is also going to be 6, because to go from here, this is sigma minus mu, and this is sigma plus mu. Does this normal probability plot appear to show a normal distribution? Don't need a lot of time to think about this. This is a yes or no question. If you forgot what a normal probability plot is, go to your book, look it up, come back. And the answer is yes. If I draw a straight line through the data, There's no systematic deviations from it. I don't see a curve like this or a curve like that. Don't see either of those. It looks to be pretty linear, so we would say yes, the data appears to be approximately normal. We never call data set normal. We always call it approximately normal, because in real life, true data is never perfectly normal. All right, the weight of gerbils in a pet store are normally distributed. The mean weight is 4.1 ounces with a standard deviation of 0.7 ounces. What is the percentage of gerbils between 3 and 4.5 ounces? So I'm going to pause. And when you have the answer, come back. All right, you're back. So first rule of any one of these is we want to do a sketch first. So do my normal distribution. All right, so the mean is 4.1. When you draw this, you have to actually put the standard deviations in the right spot, right at that point of inflection. And then you can put the other ones kind of based off that. Doesn't have to be perfect, but they kind of need to be in the right spot. So a standard deviation of 0.7 means that this is 3.4, this is 2.7, and this is 2.0. This is 4.8, this is 5.5, and this is 6.2, and this is gerbil weight in ounces. And so what they're asking us is the area between 3 and 4.5. So what is the percentage of gerbils between them? And if you'd want to draw this sketch on your AP exam if you had this question. If you have this question, you've shown you understand what it's being asked in the question. We don't have to do any fancy math things. If we wanted to, we could say, you know, what's the probability that X is between 3 and 4.5 is the probability statement. But here we're okay. So then what we want to do is take out our calculator and go to the distributions. And we're going to do normal cumulative density frequency. Our lower limit is 3. Our upper limit is 4.5, right? The gerbils between 3 ounces and 4.5 ounces. Our mean is 4.1 ounces. Our standard deviation is 0.7 ounces. And then we just paste and calculate. And the answer is approximately, oops, and that just dropped off the screen, approximately 65.8% of the gerbils will be between 3 and 4.5 ounces. All right. So then the next one is how many gerbils are under 2.5 ounces? So now we're going to go back. Hold on. What we want to do is we want to do the sketch of the graph again. It's the exact same graph as last time. So we have our gerbil weights here, and they want to know what gerbils are going to be below 2.5 and below. So that's what we're searching for. So it's going to be a fairly small percentage. And if we bring our calculator back up, then we go to distributions, normal CDF. Our lower limit now is negative infinity. Our upper limit is 2.5. So our percentage is around 0.11. But they didn't ask what percentage, they asked how many gerbils. So I have to multiply that by the size of the population. So, and we don't have to approximate this. We got the number right here in our calculator. So we just do this and we say, okay, cool. Times 150. We hit enter and we get 1.6. So, we'd say approximately 1.6 gerbils. Now, can you have 1.6 gerbils? No, you cannot. So we would say 1 or 2. But 1.6, remember, when we're dealing with statistics, you can have an average of 2.5 kids. So we can say we would expect 1.6 gerbils because it's really an average if we did it multiple times, because it's a probability. Okay, the average weighted, same thing. So what is the third quartile? So now, to do this problem, what they're really asking is, what is the 75th percentile? So we bring our calculator back up again, and we go to distributions, but now we're going to go to inverse norm, because we have the percent. It's 0.75, right? The third quartile is the 75th percentile. Our mean is still 4.1. Our standard deviation is still 0.7. And so the third quartile would be, we would expect the third quartile, Q3, to be a gerbil weighing approximately 4.57 ounces. So which of these following data sets is least likely to be normally distributed? The height of 9th graders at Freedom High School, the weight of Prince William County Schools volleyball players, or the sale of home prices in Northern Virginia? And the answer is the sale price of homes in Northern Virginia. We talked about how economic data is generally right skewed. Almost always right skewed. And if it's skewed, it's not symmetric. And if it's not symmetric, it's definitely not a normal distribution. Just a quick review. Remember what, SOX, but we've changed that to SUX. What does SUX stand for? Shape, center, spread. We have our units that we use for this. And then unusual values or characteristics of the graph. All right. Remember, another question. What is a 5-number summary? So a 5-number summary is the min, the first quartile, the median, the third quartile, and the max. So that's just a few type of questions that you might see on the test. There could be, that's just a quick brief review, make you heads up on the kind of things that we might see. Good luck on the test. I'll see you next class.